So this morning we ended up changing the design from the one yesterday where we included both the coral and the algae in one mechanism to switch to two because of the size difference of it. So to do that, we decided to use a pneumatic cylinder to actuate it because there doesn't need to be any control to it. It's just either open or close. So to do that, we used this 3D printed piece to wrap around the coral because it hugs it very closely and it works pretty well. And we're also going to add rubber on the inside so that it doesn't slip out because it's a very smooth pipe.
Okay, so we started off with gathering our components, mounting them onto our board, wiring them, and then wire management. The most useful thing I've learned today in the electrical sub-team is wire management. It's useful because things can be broken easier without it, tangled, hard to see and organize when the product is finished and say one wire breaks or snaps or whatever. It's easier to identify where the problems are. Very useful skill to have.
All right, so my team accomplished a lot of stuff in programming. So we've done 3 subsystems, which is the drivetrain subsystem, the arm subsystem, which is basically just picking up and dropping off coral. And there's also a subsystem where you can just grab the algae and just deliver it to the processor. So we've built code around those subsystems. We've used PS5 controllers to just toggle between arcade and the tank drive systems. With the coral arm system, we've actually ran into a bit of a problem here since we can't really use encoders that much. So what we've implemented was we basically introduced a toggle. So we have another controller that we use, which is a PlayStation 4 controller. And by pressing square and just holding it, it'll allow you to move the arm up and down. And by releasing it, you can just stop it completely so that it's stationary at that specific angle. So finally, for the ball mechanism, we've also implemented a toggle for reversing, for intake and outtake. So for advice, honestly, since FRC is a really good place to start programming. It's a team effort. You're mostly going to be working with teams in software engineering or just normal software development roles. So sure, you may be alone, but don't worry, there's also you also have another lead, you have a bunch of people who are working in QA. So obviously feel free to ask someone for help.
So today as a team, we were mainly focused on ensuring that the design of our robot was to be fully fabricated and fully finalized so that we could progress forward and basically have an idea of where we're going from this, as well as making sure that we still meet our deadline with the 3 days. We accomplished various subsystems such as our intake, our arm, and then as well as mounting certain parts like our struts on our robot. In terms of next steps for tomorrow, we're more leaning towards ensuring that the robot is designed to our highest degree that we can.